Hello and welcome to my channel again. Today I will start a series of lectures on different engineering concepts. I will start today with the first lecture on basic structures. Over the years when I dealt with different consulting engineers, graduate engineers, what I found, a lot of engineers have been away from structural engineering for a while. They tend to forget their basic concept they have studied during their engineering. Sometimes we all need a refresher and a fresh perspective on some of the basic concepts. So this course will cover the basic structural concepts that you need for your day-to-day structural practice. Course often referred to as engineering mechanics in some universities. In some universities, we call it basic structures. In some courses, qualifications, it will be called structures 1. What will we study in this course is the basic structural design actions. What are the different actions that act on a structure? A structure can be anything: a bridge, a house, or a simple assembly of different elements. What are the service loadings that it can be subjected to during its lifespan? Then we will look at the effects. Effects would be what will be the so always when we deal with the structures, we say we have actions, and then there is an outcome, or there is a result, and then we have the capacity. So always dealing with the structure, always keep that concept of actions. And what are the demands? Demands are basically what your structure needs to be at to withstand those loadings. And then the capacity of structures will be dealt with different material standards. Effects could be your axial forces, your shear forces, your bending moments, and then associated strains and stresses. Then second topic will cover those stresses and strains in homogeneous materials. One thing that is very important to understand is a lot of structural engineering concepts that we study have some major assumptions to support the analysis techniques that we use, or the mathematics we use. And to develop those mathematical concepts, there have been some simplifications made. Some of the simplifications is the material is homogeneous. A lot of time we are dealing with heterogeneous materials, but we will just use an equivalent homogeneous material. If we deal with heterogeneous material, it will become quite complex, but that's not a concept to discuss now at this stage in the course. We will just go slowly. First, we will look at the basic principles, and then we will look at more advanced materials concepts, or what we call as the mechanics of materials. Then we will look at the basic timber and steel design. What are the different concepts? The key concept, the first principle concepts in any code, any standard is based on some key principles. We will look at those key concepts, how we can assess the capacity of a beam, or a steel beam, or a timber beam, using the first principles. We will focus on first principles in this course, and I will give a slight understanding or slight introduction to the New Zealand practice, how the New Zealand standard assess the capacity of a steel or a timber beam. And then we will briefly look at the design of pad foundations and strip foundations. What are the stresses induced on the ground, and what are the soil reactions or the soil capacity, and how we work out those. Moving forward, first concept. So I will go a bit quick in the first few concepts, because I will assume that you have done basic forces. To do with the forces, you know what a force is, what are the different components in a space, which would be, if we write a force in vector form, what it would be. Usually when I deal with the engineering students in universities, they often have finished those concepts in their school years, because they have done some forces, they have done some vectors in vector algebra. Now, the first new concept usually the students see when they enter the university is the moment. A force is an action that tends to move an object in translational, in a unidirectional way, but a moment is a rotational tendency. The moment is when a force is applied with an eccentricity to an object. It's the tendency for rotation. Sometimes we often call it as torque, but torque is slightly different. In civil structural engineering, you will be dealing with mostly moments. And later on, we will call a bending moment. Bending moment is kind of like an internal action that you get in an object or in a structural element. But here, the first concept that you need to understand is the moment. So basically, you need to have two things. One is a translational force, and the second one is the moment arm. So in this figure, you can see that concept. And if you curl your fingers, right hand fingers, in the direction of force, you will get the moment action. So in this case, if you see the force is going towards the right, if you're looking at the screen, and if you curl your fingers, your resultant moment is upward in the z direction. So if you say I and j are for two vectors in x and y direction, your moment will be in y direction in one axis, and then the distance in the other axis, perpendicular distance. Always key, moment is always calculated by multiplying the force with the perpendicular distance, the shortest distance to the point about which you're creating a moment. So in this diagram, you can see that a force is acting at a perpendicular distance d. This is called the moment arm. So if you want to calculate the moment on point O, you multiply, this is also called scalar product. So you multiply the magnitude of force with the magnitude of the distance vector, which is just the distance. The perpendicular distance from point O to the line of action of the force. Key point here, the perpendicular distance, the shorter distance from the point where you are calculating the moment. And moments can always be in two dimensions if we are using 2 dimensions, which will be the case in this course, in this lecture. You can have clockwise or counterclockwise moments. Clockwise moments will be, if you look at the needles of a clock, in one direction it moves, it rotates, that's clockwise. If you go opposite, that will be anti-clockwise or counterclockwise moment. Now, just going back and looking at this diagram, if you look at this diagram, the force and the distance, your moment is in clockwise direction. If we reverse the direction of force, you will have moment in the counterclockwise direction. If you look at the diagram, you have 3 axes, and each axis is denoted by a unit vector I, unit vector j, and unit vector k. I is along positive x-axis, j is along positive y-axis, and k is along positive z-axis. This is called the cross product, and you have, if you have done the vector algebra vector, and then you would know that when we multiply these two unit vectors, you get a resultant unit vector of k. Now, same thing with you can do with the right hand rule. So if you always go from first to the second. So if your force is in x direction, positive x direction, and your distance is j along the y direction, so you curl your fingers along I to j, and the thumb is pointing outward, which is positive. Now, if you go in the reverse direction, if your force is in j direction, which is along the y-axis, and the distance is positive I, then your moment is negative. So these arrows in this diagram are very good way of understanding the direction of moment, or the cross product resultant signs, positive or negative. So if you use, like I said, you can follow this diagram. You have a force along I or j, and you have a distance along I or j. This way you can calculate your resultant, whether it will be negative or positive. One of the biggest mistakes I have used, or one of the most common mistakes I have seen over the years from students in their exams, is writing the signs wrong for forces or moments. Give a very good thinking about what signs you get from this product. Now, attention quiz. When I teach, I always have some questions. I always keep an attention quiz. If you're listening to me, you have listened to the previous slides that I have covered so far, almost like 7 slides, I think. If you have listened to those, you will know the answer. So I will give you a couple of moments, a few seconds, 10 seconds to absorb that information. And then I will read each one of them. I will ask you to think, use your head, use your brain, give me an answer. And then I will give you the answer as well, and we can compare your answers. The first question is, what is the moment of a 12 Newton force about point A, which is MA will be the moment. So you can see that diagram. If you look at that, F is along your x direction roughly, and perpendicular distance of 3 meters. Force 12 newtons, and the distance is 3 meters. Now, you always, like I gave you the right hand rule in the previous slide, if you do your right hand rule on paper, the thumb will always point in the moment direction. If your thumb is pointing out of the plane, out of the paper, it's positive. Into the paper, it's negative. That's an easier way from an exam point of view, or from your practice point of view. That is also one way of remembering it. So if we curl the fingers in the F direction, so if I just put my thumb roughly at the point A, and then I curl my fingers in the direction of F, it's pointing outwards, which means the first thing that we know is the moment is positive. Now we know that the moment is force times the perpendicular distance. The force is 12 newtons and the distance is 3 meters. Now the answer would be 36 Newton meters. Positive sign because it's pointing out of the plane of the paper. Now, if 36 Newton meters is the answer, then you would say your answer is B. Compare with your answers and rethink the whole thing. If you got the wrong answer, maybe you just go back and then read those or maybe listen to those slides again. The second question, using the counterclockwise direction as positive, the net moment of the two forces about point P is. So the net moment, the key here is net moment. So you need to calculate the two moments from the two forces, and then using the signs, you add or subtract one from the other. I will give you a few seconds to do that. Have a piece of paper, draw a diagram, and then see what you get. I will also upload a video on problem solving technique, what I refer to as fuse, in a future article. So before you start this course, it might be a good idea to look at that video, because that will give you some understanding of how you will approach most of the engineering problems, a systematic approach to solve engineering questions. Okay, so now if I pivot at point P, and I take, first I will look at the 5 Newton force. So 5 Newton force, I can use my right hand, and this is 5 times 2, 10, and it's going into the plane of paper, or it is going clockwise. So it is negative, minus 10. So the first number we got, minus 10. Now I look at the second force, 10 times 3, and if I just use the right hand rule, 30, and it's in positive, it's counterclockwise. So 30 minus 10, your answer should be plus 20 Newton meters, which is 20 Newton meters counterclockwise.